For centuries, the sun has been a constant, glowing beacon of light in our sky, a steady companion that governs the rhythms of life on Earth. Yet, in recent years, scientists have come to understand that the sun is anything but a static entity. It is a turbulent, dynamic force of nature, ever-changing in ways we can barely begin to comprehend. The most recent revelation, the sun's magnetic field has flipped, signaling the arrival of the solar maximum, a period of heightened solar activity that will shape life on Earth in ways both subtle and profound. This momentous event unfolded quietly, with little fanfare, at least at first. It wasn't until a group of astrophysicists at the Solar Dynamics Observatory noticed a significant anomaly that the world began to grasp the significance of what was happening. The sun, it seemed, was entering one of its most active phases. Its magnetic field had flipped, reversing the polarity of the sun's north and south poles. For most people on Earth, the sun's magnetic flip seemed like an abstract concept, something that happened millions of miles away, far beyond their daily lives. But for those who had spent their careers studying the sun, the implications were profound. Dr. Elena Marquez, an astrophysicist at the European Space Agency, had been following the lead-up to the solar maximum for years. She had been tracking the gradual increase in solar activity, and as the data from the Solar Dynamics Observatory poured in, she felt a thrill of excitement mixed with a sense of trepidation. The sun's magnetic field flipping is a signal that the solar maximum is upon us, she explained to her colleagues during a conference call. We can expect to see increased solar flares, heightened auroral activity, and, potentially, more frequent solar storms. The sun is reaching the peak of its cycle, and that means everything, from our communication systems to satellite navigation, could be affected. By the time the first major solar flare erupted from the sun's surface, a growing sense of urgency had taken hold among scientists. Solar flares, violent bursts of energy that can release as much as 1 billion megatons of TNT in a fraction of a second, were nothing new. They were a natural part of the sun's cycle. But when one such flare erupted in the summer of 2024, it was unlike any that had been observed in decades. The flare, which was classified as an X-class flare, one of the most powerful categories, sent shockwaves through space, creating a powerful geomagnetic storm. The blast sent a wave of charged particles towards Earth at over 1 million miles per hour, triggering one of the most intense auroral displays in living memory. At the same time, a surge in solar radiation began to affect communications. GPS signals became erratic. Cell phone service was disrupted in some areas. Air travel was temporarily affected as high-altitude flights were rerouted to avoid the most intense radiation. The flare, while spectacular in its beauty, was a stark reminder of the sun's unpredictable nature. A CME is a massive burst of solar wind and magnetic fields rising from the sun's corona, the outermost part of its atmosphere. When a CME is directed toward Earth, it can wreak havoc on our planet's magnetic field, causing widespread disruptions.